Functions are represented as graphs. You can't represent it as a graph unless you have a table first. Because what do we pull from tables? Ordered pairs, right? So watch the flow of this. I have a table. I turn them into ordered pairs, and I plot the ordered pairs. So the first thing we have to review is, are you plotting points correctly? Do you remember that? So if I were to say 1, 2, the 1 represents your x value. So I go 1 to the right, and the 2 means go up, right? Do you remember that? Instead of getting it reversed. What I also want you to notice about the graph is that they don't always label everything like 1, the 1 and the 3 and the 5. Be careful because they might even go by 2s. Meaning if this said 4 instead of 2, each 1 would be representing 2, right? So be careful of that. So table, ordered pairs, and now we're introducing this third piece of this puzzle today, which is a graph. So let's take a look at what this is going to say. This is going to say, here's a domain, here's the function. Yesterday or Friday it said make a table. Today it's going to say graph it. So this is where we pick up at. So we are going to represent a function as a graph today. All right, it's going to give you a domain. So go ahead and copy this down. The domain is 0, 2, 4, 6, and 8. And the function is y equals 1/2 x. Graph it. Okay? So in order to graph, you need some points. And in order to get your points, you need a table of values, right? So, but before I can even do that, I need to figure out what my range is. So I'm going to start, everything starts by making this table of values. You have to know where to put your domain. It's your x, right? Your range is your y. So I'm going to put 0, 2, 4, 6, and 8 here, okay? This is no different than what we've already done. And the book was so nice that they gave you even number domains because you have to take half of them. I would rather take half of an even number any day than an odd, right? So put 0 right here, multiply it by half, and then you get your output. What's half of 0? 0. Put your next domain, your next input is 2. What's half of 2? So your y is 1. You with me? Take half of 4, that's your input. Half of 6, half of 8. And so now that I have my order or my table, this next step is optional. And I know what that usually means in middle school. It means you don't want to do it. These represent ordered pairs. So the first ordered pair I'm going to graph or plot is 0, 0, followed by 2, 1, 4, 2, 6, 3, and 8, 4. Okay? If you need to see them written in parentheses in ordered pair form to graph them, go for it. If you are able to go right to plotting your points from your table, go for it, okay? Let's talk real quick about an empty graph. So an empty graph means you have to do the labeling of it. So it's not a bad idea to go ahead and label which one's your x and which one's your y. Or maybe this is your domain and this is your range and you want to write it like that. Now, let's talk about this for a second. When I look at my domain, I look at these numbers. I always want to see how high do I have to go. Because when you have to put your own tick marks and stuff in, if you have to go up to 100, are you going to start going by ones? No, you have to use some common sense. You're not going to go by ones to get to 100, maybe by tens, right? So if I only need to go to 8 for my domain, do you think I have room to go by ones? Yeah. So I'm going to evenly space them. Am I going to like bunch them all up next to each other? No, you're going to use the full axis. So 1, 2, 3, 4, 5, 6, 7, 8. And you just have to eyeball it. At this point, you can decide if you're going to put a number on every single one. Sometimes it gets a little crowded. So sometimes it's nice to just put maybe every other one. Okay? And you know that they have to go the same increment. Like I'll show you something in a little bit about a break in the graph. Okay, what's my range? I only have to go up to 4. So now I could go just 1, 2, 3, 4, but that's kind of annoying. Do you know what I mean by that? Because then your whole graph is taking place right in this little rectangle. I want you to utilize as much of the graph as you can. So you know what? I'm also going to make 8 tick marks, except when I label it, this is going to be 1, skip 1, 2, skip 1, 3. So I'm kind of accounting for halves in there. Does this axis have to match this axis? No. Okay? So did you see how I kind of just created a nice looking graph? And now I want to plot my points. My 0, 0 goes right at the origin. My 2, 1, and then 4, 2, and you're just plotting away from here. 6, 3. I'm going to give you actual graph paper today, so you're going to be getting a whole page of these, which will be nice because it's so frustrating having to do it. I get it. And then 8, 4. Don't connect the points right now, okay? Do not connect. Okay? Because they're telling you that your domain can only be 0, 2, 4, 6, and 8. What I mean by that is this. If I follow these points back down to the x-axis, those are the only points that they can be. So my domain can only be 0, 2, 4, 6, and 8. If I connected these dots, what are you telling me? Yeah, good. Ben is about to say that it could be anything in between 6 and 8. Like it could be 7, but no, it can't because it's the domain that was given was 0, 2, 4, 6, and 8. So don't connect right now. That's going to be huge later, okay? You want me to show you something else kind of cool? What was the resulting range? Well, the range resulted in what I follow over to the y, because isn't the range y? So that just kind of shows you that, you know, this followed down here is your domain, but followed over to the left on the y-axis is your range, okay? Good. So guess what we just did? Listen to this vocabulary. Are you ready? We took a function with a given domain. We created an input-output table that we made ordered pairs, and then we graphed it. So is this the graph of this function? Yes. Did you follow that? So really, that's what we did last lesson with that graph added in. Okay, so sometimes they're going to give you a table of values already. So I want you to take a look at this example right here, if you're with me on page 45. So this is kind of funny. We were just talking about the SAT. So here are the SAT scores that were the average in the United States from 1997 to 2003. Okay, now look at this. Notice what your input is. Your input is the years since 1997. So if it's year 0, what year does that represent? 1997. Year 1 would be 98, and so on. You guys can figure that out. You know why? Because on my domain, my x-axis, I don't want to put 1997, 1998, 2000, 2001. So you have to understand what these mean. And then S is your score, okay? So basically what it's saying is take a blank graph and plot these points. So I don't want to show you the solution yet, because when I go ahead and do what I did before and I plot all these points, are you going to expect to see a straight line? Looking at the data, I saw some kids shaking their head. It goes up from 511 to 512, then back down to 511, and then it has no change 1 year, and then a pretty steady jump here. So what you have to be able to do is take this, label it, and it tells you this is your x, which is your independent variable. So what's going to go on this axis? T for time. And on this axis is going to be your score. Well, let's talk about this. What's the lowest score you need to go to? 511. So, man, how am I going to even think about labeling my axis here? Have you ever seen something like this before? The little squiggle, okay? It's called a break in the graph. And what that means is if I'm going to label this and I got to go all the way up to 511 as my first data point, you going to go by ones? Are you going to go by 50s? Even if you go by 50s, when you get up to these points, they're not very spread apart. So what this is saying is, yeah, I know my increments don't all represent the same amount. Because without that, you can't put 510, 540. He's going by twos, right? So keep that in mind when you see that. So first thing I want to point out is it's not a straight line. That's right. All functions are not straight lines. Is this a function still? Does it pass the vertical line test? Yep. Somebody said, what about these two though? What do two horizontal ones right next to each other mean? It means that in year 1997, 98, 99, it means in 2000, the average score is 514. And in 2001, it was still 514. So the horizontal line means no change. And that is represented by that right there, right? So a lot of what we have to learn how to do, I know you're not writing anything down, but this is using the book. Does this make sense? A lot of these notes here. So if I were to say, between which 2 years was there the greatest improvement in scores? What would you look at? And it actually happens, there's the same increase twice. Give me between which 2 years, Ben?
5 and 6.
Okay, between year 5 and 6, but you know they're going to ask you for, if this is 97, this is 1998, 99, 2000, 2001. Between 2002 and 2003, it increased 3 points. Where else did it also increase 3 points, Dominic?
1999?
Yep.
2000?
Yes. And between what 2 years did this average score drop? Between 1998 and 1999. Okay? So that's just a quick little helpful hint here on how to do that. Okay. So now here's the next step. I'm going to give you a graph that's already been graphed and ask you to write the rule for it. So let's think about this. If you can take the ordered pairs with a domain and put them in a table and put them on a graph, can you go backwards? How would you make the equation from the table? You would take the points off the graph, put them either into ordered pairs or straight into a table, and then you would do what we did Friday, correct? Okay, so let's try that. So let's take a look at this graph right here. All right, this one, you have it in your book, but let's take and pull these points out of here. So what's the first point that you see? What's the name of that point right here? Let me zoom in. The name of this point is what? 1, 2. Could I just do this right here? Do you need ordered pairs? If you want them, go for it. Dominic, what's up?
I was gonna say.
Oh, okay. What's the next one? I don't want the rule just yet. 2, 3. You think that pattern keeps going? 3, 4. I probably have enough information, but just keep going. 4, 5, and 5, 6. All right. Anybody see a connection between what's going on in here? Yes.
Y is x minus 1.
Not.
Plus 1.
Yeah. So x is y minus 1, but the y value is equal to, every one of these y values is equal to whatever the x value is plus 1. Agreed? Okay. So now we need to kind of talk a little bit about some harder ones. Because as I have you look at this one, I want you to see if you're able to do that. Like my last hour was not able to come up with a rule that would be represented by these two graphs. So I'm going to give you a second to see if you can come up with that, and then I'm going to show you a way around it when it's not one that sticks right out.